right, greetings, points of lights. Hope you gentlemen are doing well. Let's see. So let me see if there are any announcements. We're going to go ahead and get started. This should be college algebra with lab. I still need to contact my colleague. So one piece of information. I do want to make Alex our lab component. I just need to reach out to my colleague to make sure she's still orchestrating that. And then, but basically, you should already have an Alex account that associated with Morehouse. Just keep working that, and she usually sends me an update of who's been doing what on Alex, and that's like 10% of your grade. The main thing is just to keep working through Alex. Depending on your level, everybody needs to do at least like 25 topics per week. If you're at the prep for pre-calculus, you need to do like 40 topics per week. And if you're at prep for college algebra or lower, you need to do like 55 topics per week. The goal with Alex is by the end of the semester, everybody should be at least at the level of prep for college algebra. Okay, so that's one piece of information. Let me let the student in. But I hope this presentation finds everybody doing well. You know, just living life and one of my favorite phrases or quotes is, do your best, forget the rest, don't stress, and be blessed. Because at the end of the day, that's all that you can do. You can do your best. You know, you can't worry about the rest of it. So that's why I say that kind of stuff. It seems very like silly, but then when you get pushed up against the wall and life starts, you know, taking those blows and jabs at you, that's, you know, all you can do is all you can do, and then beyond that, you know, it is what it is. And but the ability to let things go, I honestly think saved my life. Like I honestly, like not trying to have every little thing my way and stuff like that. One of the best practices that I can think to invoke. So with that being said, let me see. So aside from officially letting Alex be our lab, again, I just need to contact my colleague to make sure that she still is offering that service. But as a Morehouse student, you should already have an Alex account, so you can kind of continue doing what you're there. Everybody needs to do at least, most people should be doing about 55 topics per week, especially with this course. And that's going to count as our lab portion. And I'll just kind of keep reminding us with each session. And I am monitoring the chat, so feel free to either unmute yourself or type in the chat if you have questions about anything. There should be a version of this full lecture for section. Honestly, I think I have the entire semester on my YouTube channel. So my YouTube channel is Beautiful Mind Pfeiffer. I am streaming this session and all of our sessions live there, so you can go there for a copy of our sessions, like basically what I'm streaming. Let me let the student in. Boom. And so again, with our classes, I am holding our classes as asynchronous. All you have to do every time we have a session, just check in, get your attendance credit. If you don't have any questions, you don't have to stay. But I'll be here. My intent is to use the class time to work through as many homework questions and just answer as many questions as possible. And again, all of our lectures are pre-recorded. They are loaded on my YouTube. So my expectation is for you to watch those videos in advance. So go to, like, it should be a playlist that says College Algebra for this, you know, this term, College Algebra Spring of 2021. And like for right now, this week we're working on section 1.1. So you would watch the pre-recorded video lecture on section 1.1, take notes as if you're in class, write down any questions that you have, and then once you're done with that, then, you know, be sure to do the homework that you access through Blackboard. So we are working assignments via Pearson, but I linked it to Blackboard. I haven't updated the gradebook yet, and I will. And I think you do have to purchase full access to Blackboard. It's like about $120, give or take $10, to gain full access. But that's going to be the bulk of our grade. And then with the assignments, so the anticipated rhythm for our assignments. So at least, you know, a homework assignment for every section for each week, a weekly quiz, and then a monthly exam. So we have about 3 months. So that works out to about one exam every month. So our first exam is like at the end of February, like February 28th, somewhere like that last week. It's going to pop up on that Wednesday, and we do that Sunday. So if you want to like maximize your point value, you would submit it by that Sunday, and you'll see it when it pops up. You'll have about, from Wednesday to Sunday, you have a few days to work on it once it pops up. It should be over the first half of chapter 1, so 1.1 to 1.4. But with all the assignments that we have via Blackboard, honestly, you get unlimited attempts at all the assignments, homework, quizzes, and exams. And you can actually submit assignments past the due date. On a weekly basis, our assignments are due Sundays at midnight going into Monday. But if you submit it late, it's a 10% late penalty. So even if you submit it late, if you really want an A, you would just have to get a perfect score, and you can actually get, it would be like an A minus on those assignments submitted late. Again, so like if you have questions, feel free to type it into the chat or unmute yourself. Otherwise, I am going to hop into some more problem set and just kind of keep going where we left off from last time. So the way I kind of did it last time, it is kind of keeping track of what we've done. So I think we made it through about 5 questions last time. So we're just going to continue with question 6 here. Okay. All right. And I'll leave that because I know I'll have people coming in and out. So we're asked to graph this, right? We have this, it says graph y equals 4x plus 6. So notice this is going to be a straight line. Now I really want to ask a question, why is it, how do you know that it's going to be a line? But that technique is a little bit difficult via Zoom because it's just a little bit challenging because we're not in each other's presence and I can't see your face. But that's okay. But the reason I know that this is a line, the highest exponent on any variable is 1, right? So to graph a line, this is in the form the slope-intercept form, y equals mx plus b. So in this form, the easiest way to graph it, the b is going to be our 6. That's our y-intercept. So that means we will start on the y-axis at 6, and then the m, which is our slope, is right in front of the x. So the slope here is 4. So let's put that together. So we have the y-intercept is 6, and the slope is 4. I'm going to click to enlarge our graph. So again, the highest exponent on any variable is a 1. So that tells me that it's a line. So I'm going to click on the line tool. The y-intercept is 6. So I'm going to go up to 6, start at the origin and go up 6 and put my first point. So to identify a line, we need 2 distinct points, right? So we have the first point. And then we use the slope to find the second point. That slope being 4, which is the same as 4 over 1, it means we go up 4 and over 1. So that means if we go up 4, we're going to go up to 10 and then right to 1. So then that should be a second point. So this line should identify all solutions or ordered pairs of that equation. So I'm gonna hit save. And again, this back discussion is in my pre-recorded lectures. Okay. Let me see if there's anything else. Yeah, let's keep going. So then we're asked to, let's see. So this is number 7. Graph the equation by plotting points. Okay. So let x be these values, right? So what the technique they're using is perfectly fine. You can make a table. I guess I could do that. Yeah, I'll do it. I was gonna go ahead and jump into transformations, but that would actually be jumping the gun. So instead of jumping the gun, I'm gonna do it the way that they want us to do it. So first, I need to take some notes. Ooh, that's kind of messing with my eyes. That's better. Let's see, hopefully this isn't lagging. So this is question number 7. I can suppress that now. I think so. Okay. So let me just take some notes before I hop over to the tablet. So this is this comes from section 1.1. Yeah, it is lagging. Hang on, I gotta reboot this thing. Oh, I didn't mean to close that. That's okay. Let me open this back up. Oh. Yeah, I knew that was gonna happen. Close this out. Give me a moment. I closed out a window I didn't mean to close. So I'm gonna log back in. Nope. Right there. Okay, that looks good. Let's go here. Click. Here. Come on. This one. And so I think this is still the lab class, but I'm just going to use, I know we have 2 links in Blackboard to access our course. I'm just going to use the one link. So there's going to be one where everything is going to be populated. I'm just going to use that one link every time. Attendance. Okay, that looks good. I just needed to show. And okay, that looks good. Oh, I forgot the other ones. That's okay. And then I'm going to open up this. let's go back here. My pen. Okay. So this comes from section 1.1, graphs of equations. Graphs of equations. Okay. Let's see. This is question number 7, and this question comes from 1.123. So hopefully you know what that 1.123, that's the question ID. That tells you where in the book it's coming from. So this question comes from section 1.1, question 23 out of the back of that section. We're asked the graph. We have y equals absolute value of 5 minus x. There's a way we can actually just look at this and get the graph, and like through transformations, but I'm going to use the technique they're suggesting and save the other part for a little bit later. And then it says let x equal 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. Okay. So now let's hop over to the tablet and see how we can work this. So let's go here. Okay. I'm going to suppress this, and I think I can suppress that as well. Okay. Let me see. Can you guys? Yeah, you should. The audio looks fine. Okay. So we're going to graph this, right? So let's make a table. So we're given our x values. We want to find the corresponding y values. Okay. We said let x be 3, 4, 5, 6, 7, 8, and 9. Okay. So then I'll use this color. So I guess we can write it out. I mean, that shouldn't be necessary. So when x is 3, right? Yeah, we'll write it out. So when x is equal to 3, then we're going to have y is going to be what? The absolute value of 5 minus 3, which is the absolute value of 2, which is 2. Again, absolute value is the positive distance away from 0. Again, at any moment, if anything is not clear, feel free to either type it into the chat, your question, or feel free to unmute yourself to get my attention. Okay, so when x is 3, y is 2. Let's do when x is 4. So this app has done updates where you can undo by double tapping 3 fingers. I was like, okay, I like it. They have some other gestures. I can't think of them, but I'll pull them. Absolute value of, what is this, 5 minus 4, all right? 5 minus 4 is 1, so absolute value of 1 is 1, okay? So then when x is 5, and you don't really have to do it this way. I'm really doing this for instructional purposes. It goes much faster once you get the gist of it. But I'm just doing this to introduce the idea. 5 minus 5. So that's going to be the absolute value of 0, which is 0. Again, absolute value is a positive distance away from 0. Okay. So then when x is 6, that's going to be y equals 5 minus 6. Oops. 5 minus 6 is going to be what? Absolute value of negative 1. Absolute value of negative 1 is 1. Absolute value is a positive distance away from 0. Also, all these things that you see me writing, I will make these available on our Blackboard page. There should be a folder that says like, I still need to update some of that stuff, but I'll make these anything you see me writing, I will make it available for you. So when x is 7, all right, absolute value of 5 minus 7, so it's going to be absolute value of negative 2, which is 2. And then it should be 3 and 4. I'll just leave that. Well, let's go ahead and do it. Let's go ahead and do 8. Absolute value of 5 minus 8. Absolute value of negative 3, which is 3. And then when x is 9. 5 minus 9, negative 4, which is 4. Okay. So I went on and showed everything there. Let me do the following. No? Let's try that again. Draw a line. Oops. Looks good. And then let's draw a line here. Nope. And let's do one here. Okay, that's fine. And then let me just do this. Okay. All right. So then let's plot these. Let me get a copy of this. Copy. I'm just going to paste it down here, give myself some space. All right. X's go from 3 to 9. Y's go from like 0 to 5. So the right and the positive. So let's look, we're talking about quadrant 1. So I'm going to put like the origin, like put it here, right? Let's see. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. That should be more than enough. So this, oh, let's do this. This represents, let me try that one more time. Okay. That's the positive x-axis going off to the right. Positive y goes in this direction. Okay. This was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This was 1, 2, 3, 4, 5. And then I'm just going to switch the view. I like this for this kind of stuff. Okay. This works a little bit better for me. So let's plot these points, right? So when x is 3, y is 2. So then we have this guy here. Let me just copy and paste. Okay. When x is 4, y is 1. So if we go over 4 up 1, we have a point there. The next one, when x is 5, we're at 5, 0. And then I think we're at 6, 1. And then 7, 2. And then 8, 3. 9, 4, so on and so on. The pattern continues in both directions. Okay. So then if we connect all these points with a straight edge, we get the following. What do I do that? Let's do this. So like that. And then there's one here. That looks good, right? So we get an image like this, right? So then if we hop back over, to Pearson, so let's see. It's going to be this one. So then we should have there should be a graph that matches that exactly, and it should be evident. It should be D. Okay. There is a fast way to do that, a faster way. Faster does not always mean better though. Like it's just another way of doing it. But plotting points is, if you have a question, go ahead. You can type it or feel free to unmute yourself. Pardon? D? Mm-hmm. They should. Are they not doing that? Yeah, yeah. So those videos are like give the backstory to what I'm doing here. If that makes sense. Yeah, that's a good question. All right. All right. So that one was fine. So we did that one from scratch. You know, we saw the evolution or the development of that idea. Let's go on to the next one. On to the next one. Graph by plotting points use -2, 0, and 2. Let me see my time. Let me do this one a little bit faster. So I'm just going to do it directly on the chart. So now when I look at this, the highest degree, in the last one, the highest exponent, in the first one, the highest exponent was a 1. The previous one, we had absolute value. So the general shape for absolute value is a V. When the highest exponent is a 1, the general shape is a straight line. This one, the highest exponent is a 2. College algebra, right? Okay. Highest exponent is a 2, so that's going to make a parabola. So yeah, let's just plot some points. So I'm going to click to enlarge. We're looking when x is -2, 0, and 2. So it should make a U-shaped graph, right? So when x is -2, so -2 times -2 is going to be a +4. 9 minus 4 is going to be 5. So when x is -2, y is 5, right here. Okay, come on, right there. And then when x is 0, y is 9. So we're going to go here. And then when x is 2, we get the same thing of 5, I think it was, right? 9 minus 4. So then this is the shape that we get. So we just did that by plotting points. Okay. So check the answer. Okay. Let's go on to the next one. So write the x and y intercepts of the graph. Okay, so we need to look at the graph. So the x-intercepts, all right? Let's see what we got. Pop out. X-intercepts, okay. So you can see from here, if this is the origin, let me see, -1, 2, 3, 4, 5, 6, 7. So this is -2 and +2. So the x-intercepts are ±2 and 0. Round to the nearest integer, use a comma to separate as needed. So it looks like our x-intercepts, -2, 0, 2. And then the y-intercepts. So, and honestly, like if you wanted to like work on your homework alongside me, you can, but just be aware that your numbers are going to be different. And you can always you should be able to pull this back on my YouTube channel and reference, pause, rewind, do what you need to do to see it. Where it crosses the y-axis is the origin. That looks like what, 5 ± 5. Okay. So ± 5 in the origin. And I'm intentionally putting these numbers in order. A lot of this, it doesn't really matter, but sometimes it does with the way these things work. Okay. Without sketching the graph, find the x-intercepts and the y-intercepts. Okay. I want to write this one out. This one we need to take some notes. Okay. So this is question number 10 from this section. It comes from section 1.1, question 33. It says without sketching, so I'm going to say find the x and y intercepts. Okay. Let me switch my paper back to grid paper. I don't know why that's doing that. That's a little bit irritating. Oops, probably should have just started pressing buttons. That's okay. And then the equation. So we're given this 3x plus 2y equals 12. Okay. Now let's hop over to the tablet and see what notes we're taking. It looks good. Okay. So find the x and y intercepts. Now, if we were in each other's presence, this will be a moment where I would ask you guys, okay, how do you find the x-intercept? Like, if you go along the x-intercept, what's consistent all along the x-intercept, right? So, like, you know, that's why I would ask if we're in person. But I'm just going to say it for the sake of this. So to find the x-intercept, the value of y is 0 all along the x-intercept. Similarly, to find the y-intercept, the value of x is 0 all along the y-intercept, right? All along the y-axis and the x-axis, right? So let's start off with the x-intercept, how to find that. So to find the x-intercept, what we do is we set y equal to 0, right? Because all along the x-axis, y equals 0. Okay, so if we set y equal to 0, we're going to have 3x plus 2 times our y equals 12, and we just said let y be 0. Okay, so 2 times 0, this goes to 0. So then we're left with, if the equal sign comes down, now I usually like to draw like a vertical bar to line up my equal signs. All right, so my equal sign just comes down just for organization. The second term has gone to 0, so anything plus 0 is itself. The 12 comes down. So like in life, what you do on one side, you do to the other. So to move that 3 to the other side, we're going to divide both sides by 3. All right. A number divided by itself is 1, and then 1 times anything is itself. So on the left, we're left with x. On the right, what is that? 4. So when y is 0, x is 4. So then the x-intercept should be 4, 0. So it should cross the x-axis at 4. All right. Hopefully that made sense. And like, you know, one of the biggest things that I could say about this college experience is totally different because of, COVID and all this. But with this thing, you got to be sure to get your questions answered. Did that? No, it didn't. Yeah, be sure to get your questions answered. If you don't ask me directly, at least communicate with your classmates or somebody. A closed mouth don't get fed. If you don't say anything, by the time it surfaces, it can be kind of bad. But you just want to do your best to get your questions answered as early as possible, as soon as possible. And just honestly, if you just, by the time you finish doing the work yourself, you'll get it. And like, it takes a little bit of effort to figure out things initially, but once you figure it out the first time, then anytime you see it beyond that, it's just you practicing to improve your skill. So to find the y-intercept, similarly, we're going to set, let's use a different color. We're going to set x equal to 0 to find the y-intercept. So set x equal to 0, right? So then we're going to have 3 times x plus, I think it was 2y equals 12. Let me move this stuff over, give myself a little bit of space. Just want to move it this way, so. And I can move this over, give myself a little bit more space. And I just want to rewrite this stuff because I was getting a little bit jammed. 2y equals 12, okay. And we said let x be 0 in this case, okay? So then similarly, any number times 0 is 0. I'm going to draw my vertical bar just for staying aligned. Okay. The 2y comes down, my equal sign comes down, and my 12 comes down. And then to move that 2 to the other side, we're going to divide both sides by 2. It's the same reasoning as the previous. Y equals, what is that, 6? So then the y-intercept is going to be 0, 6. Okay. All right, that looks good. All right, so let me see. Yeah, that's about all we can do there. So that's how we would do that without graphing. Let me hop back to Pearson. Okay, so the x-intercept, we got 1. We can get some light going. It's kind of dark in here. Ooh. Is that not? I guess not. Oh, there we go. Okay. Let's see. So let's check our work. X-intercept, we got, oh, that light is not working for me. It's totally like distracting. Where's another one? Give me just a moment, I'll be right back. So the x-intercept is 4, 0. Parentheses 4, 0. And I know it seems light right now. Don't just be weird. Oh, yeah. Sorry, they don't want an ordered pair. Yeah, sometimes it's just they just want the right format. And then the y-intercept is we got 6. Thank you. Thank you for that. All right. All right. Okay. So that was, I mean, we didn't have to do all that, but again, I was just doing that for instructional purposes to show all the details. It goes much faster once you do it on your own and you get the gist of it. You don't have to show all those details. I was just doing that to introduce ideas. Okay. Without sketching, find the X and Y intercepts. I think I'm going to write this one out as well. This one's going to be a little bit involved. So this is number 11 here. So this is question 11. Comes from section 1135. I'm going to say find the X and Y intercepts. Okay. We have y equals x squared minus 2x minus 15. Okay, that looks good. So let's hop back over to the tablet here. All right, let me see what the time is looking like. We're looking good on time. All right, so I usually like to start with the Y-intercept. I think they do the X-intercept first. So let's find the X-intercept. Okay. So to find the X-intercept, hang on, I was just trying to match my colors from whatever I did before. Okay. So to find the X-intercept, we set y equal to 0, all right? So on the left, we're going to have 0 equals x squared minus 2x minus 15, right? So this is what I generally like to do the Y-intercept first. Probably going forward, I will do the Y-intercept first. I'll go ahead and finish this one. So now we have, what kind of polynomial is this called on the right-hand side? See, if we were present, that's what I would ask. How many terms? We got 1, 2, 3. Terms are things that are added and subtracted, right? So this is a trinomial. It is expected that you already are comfortable with factoring. I am aware that most students are not comfortable with factoring. If you would like some added practice on factoring, let me know. One thing is that's what Alex, the lab, is supposed to do. It will help address some of the factoring. That's why I like it. It's tailored to kind of fill in gaps for each student. So like whatever level you're at, it's supposed to address any kind of deficiencies. That's what I really like about Alex. It's customized for each student. Because factoring is just one of those things. It's not obvious. And the only way you really get factoring is through exposure, experience, and practice. Dang, I needed another X. What's an X that means practice? Exposure, experience, and dang, if I had another X word, that means practice. I could fit that trilogy, that trifecta or whatever. Anyway, but yeah, if you're not comfortable factoring, let me know. I can get you some. Again, Alex is supposed to address that, but I have like some other material that I'll make available that'll walk through pretty much all the factoring scenarios that we'll come across in this course, right? So factoring a trinomial where the leading coefficient is 1, we're going to have x and x. We're looking for two numbers that multiply to give us negative 15 and add to give us negative 2, right? So what I'm going to do, I'm going to actually go down the list of all the factors of negative 15. All right, so off to the side, I have negative 15. That's going to be, what, negative 3 times 5, right? So I'm going to go through the list. So first pair is 1 and 15. That adds up to 14, so those are not the two numbers that we're looking for. Is there a 2? There's no 2, but we could do 3. 3 and 5, and these add up to positive 2. These are close, but no cigar. So only thing we need to do is switch the signs. We're going to say 3 and negative 5. And these are the two numbers that we were looking for. Okay, just being silly like this. Okay, so let's use those two numbers. It's going to be x minus 5, x plus 3, right? And we could always FOIL to check. We can like distribute, re-multiply back. Notice that negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. Okay. So now at this stage, we want to apply this technique called the zero factor property. let me put that off to the side. So this step, we want to, the next thing we want to do is here, use what's called the zero factor property. I'm not going to lie. I really like writing on this tablet because like during class, if we were in each other's presence, I would either be trying to use multicolored markers and trying to like constantly running out of ink and like the markers drying out. And it's just a lot of like, man. Or if I was on chalk is so messy, it feels so weird on my hands, gets all of my clothes, you know, getting dirty. This, as long as I got power and internet, man, it's so clean, it's so smooth. I love it. Like, I be having so much fun. And then, like, my goal is I'm going to get to a point where, all right, guys, see you next time. I'm going to shut everything down and I'll be on the beach, you know, like on my private island. Like, that's where I'm headed. Shoot. I'm going to do it. I'm the type that'll figure stuff like that out and just do it anyway. But yeah, so the zero factor property, right? Just a little bit of manifestation and dreaming, you know. So the zero factor property says that when we have two or more things that multiply to give us zero, then either the first thing equals zero or the second thing equals zero, right? So at this stage, all we do is set each thing equal to zero and solve, right? Because if either one of them is zero, it's going to collapse the whole thing down to zero, right? That's the zero factor property. So again, all we do, let me try to be consistent. So we're going to say this x minus 5. We're going to set that equal to 0. Let's do this to show that we're applying that property. And then we'll say or x, plus 3. We're going to set that equal to 0. Okay, so that's the zero factor property. So then we just solve. We add 5 to both sides. So we can do, this color's fine. Let's do this. So then we'll say plus 5 and plus 5. The equal sign comes down. Let me move this over so we know that. Let me undo. And let me include my bar like the other time just to be consistent. That's fine. Okay. On the left, we're left with x. On the right, we're left with 5. Okay, and then similar for this other equation. Let me do the following so I can see it better. And then like this. And then we're going to subtract 3 on both sides. On the left and right side of the equal sign. That adds to 0. The x comes down, equals -3, right? So our claim is that when x is 5 or x is -3, that makes y equal to 0. Okay. So the following is what made me fall in love with mathematics, is the ability to check our answers, right? So what we're saying with these two results is that, you know, when we plug it into the original, we should get 0. When we get these answers and we don't check, what we're saying is, oh, I've been in school at least 12 odd years, however long to get to this point. This answer may or may not be right. I'm just going to leave it up to chance. But then when you check, you drastically boost the odds of success in your favor. Remember, chance favors the prepared mind, right? When I was a student, that's how I maximized my points. I'd be on an exam, I get an answer. I was like, what does this answer mean? Does it make sense? I would check it in the context of the original. And that's how I would minimize my mistakes that way. But in like literature, I didn't have that as an option. I had to, it just didn't work for me. So, so that's why I was like, you know what? I'm just going to empower myself. And that's why I went into mathematics. And I just pretty much getting paid to have fun. I hadn't looked back. I figured out a way to get paid to have fun. I hadn't looked back. Okay. I just want to show you this. So I'm going to show you the technique. We can write it out, but I want to show you the following. I think I did something like this last time, but I'm going to just do it again now. I'm going to pull up my trusty, dusty, rusty calculator and show you like in the TI-83 Plus. And there are other ways of doing what I'm about to do, but I'm going to show you on this graphing calculator. Let's get a time. We go 5:15, 6:30. Okay, cool. So I want to just check these numbers in the original, right? And I know this is a simple example, but I'm just showing you some of the capability. So we have this x squared minus 2x minus 15, okay? That's the y that we had. I'm going to quit. To the left of the variables button, right here, it says, to the left of the clear button, it says VARS. I think it stands for variables. I'm going to click there. At the top, I'm going to go to the right to go to y variables. I'm going to click on number 1 and to call the function I just typed in. So our claim is when x is 5, the output should be 0. When x is -3, I just recall, when x is -3, we should also get 0, right? So that's good enough for me. Okay, I'm going to get rid of that. All right. So I feel confident about those x and y intercepts. That's the x-intercept. We got -3 and 5. I'm going to leave them where they are. And then for the y-intercept, we set x is 0. So let me go ahead and do that. So for the y-intercept, let's see what color did we use last time. We did green. We're going to set x to 0. Come on, stop. We're going to set x to 0, right? Let me get a copy of the function here. Copy, paste. Okay, so if we're going to set x to 0, we're going to have this y equals, now when I'm doing my substitution, I'm going to replace each x with a blank set of parentheses. So we get x squared minus 2x minus 15, okay? And then we're going to let x be 0, 0. Okay? So then you should notice this first term goes to 0, the second term goes to 0. Only thing we're left with is this -15. So that's usually why I do the y-intercept first. It's oftentimes much easier than the x-intercept. Those zeros cancel out a lot of the terms, and the only thing that's left is this -15. Okay? So we got our y-intercept, we got our x-intercept, and you can see all the work right there like that. Boom. Okay, from beginning to end. Let me check the chat really quickly to see if we have any questions. Cool beans, we're looking good. So let's hop over to Pearson and check our work. We checked it as best we could on our end before we submit it. X-intercepts, we got -3 and 5. Integer or simplified fraction, okay, -3, 5. Okay, and then the y-intercept, we got -15. Okay. All right. All right, let me see the time really quick. Let's move on to the next one. Next question. Without graphing, determine whether the equation has a graph that is symmetric with respect to the x-axis. Oh, symmetry. Yeah, okay, we can talk about symmetry. Let me take some notes. Let me see if I can, that's the simplest way to introduce this idea. So this is question number 12. Let me give some backstory. This comes from section 1.1, question 41. I'm going to say determine whether this is symmetric. So I'm just going to put symmetry and question mark, right? Does it have any symmetry? And we have this y equals x squared plus 10. Okay. Let's hop back over to the tablet and let me give you some backstory there. Okay, so we have 3 types of symmetry. I'm just going to talk about like the things I feel like I need to say as far as symmetry is concerned. Let's start off with y-axis symmetry. So an example of a figure that has y-axis symmetry. So say this was the positive x-axis. Let me do the following like this. Say this is the positive x. Say this is the positive y. All right? And say we have a figure that looks like something like this. This is not going to be drawn that well, but something like that. All right? Notice how we could fold this in half along the y-axis, and the left-hand side is going to match the right-hand side, right? So we can fold it, and they'll match up. This is an example of something that has y-axis symmetry. So this is an example of something that has y-axis symmetry. Okay. So one thing to note whenever we have y-axis symmetry, whenever we have the point x comma y on the graph, we also have the point, let's see, something like this, right here, this guy here. This is the point, oh my goodness. These alarms about to give me a heart attack. Whenever we have the point x comma y, we also have the point negative x comma y, right? So no matter what x comma y we choose, there's always another point that has this negative x comma y. That's a property of y-axis symmetry. So to test for y-axis symmetry, what if we look at these 2 points? Notice what changed, right? We have an x comma y, we have negative x comma y. So the only thing that changed was the x's. So no matter what x we choose, we got the same y. So that's how we would do a test for y-axis symmetry. We would change x to negative x, simplify. If we get back the same y, then we can say we have y-axis symmetry. Let me give a little bit of backstory on x-axis symmetry. It's a similar discussion. So let me get a copy of this. Let's copy. Actually, let me do, I want that, and I want this. Let's copy and paste. Boom. Okay. So let's do an example of something that has x-axis symmetry. Let me kind of do this. Okay. So an example of something that has x-axis symmetry could be, I'm going to do this shape. Something like that. Right? This is an example of something that has x-axis symmetry. Why do I keep doing that? Symmetry. Okay. So in this case, whenever we have x comma y, what do you think changes here? If in the last one the x is changed, what can you anticipate changes here? Right there. So whenever we have x comma y, we also have x comma negative y. So your intuition should have said, oh, well, maybe the y's are going to change in this case. And that's exactly what happens. So with x-axis symmetry, whenever we have x comma y, we also have x comma negative y. Notice you can fold it in half along the x-axis, and the 2 halves are going to match up. You always have these points that are equidistant from the x-axis when you have something that has x-axis symmetry. And let me just do an example of the third type of symmetry that we could come across. That's fine. Okay, so the third type, let me see, we did, okay, I'll do orange. So the third type is origin symmetry. Origin symmetry. Okay. An example of something that has origin symmetry is going to take on the following kind of shape. Something that looks like the following. So it can go, oh no, my battery just did that losing power sound, and I keep having these different alerts and alarms that go off that kind of spook me a little bit. So it'll go something like that, and it'll do something like that. All right. So with origin symmetry, whenever we have a point x comma y, so if with y-axis symmetry the x's change and x-axis symmetry the y's change, what does your intuition say is going to change in this case, right? Whenever we have x comma y, we also have another point negative x. Nope, that's not an x. Negative x comma negative y. So they both change with origin symmetry, right? So that's the gist of the backstory I wanted to share on the 3 types of symmetry that we'll have. Y-axis symmetry, whenever we have x comma y, then we also have negative x comma y, the x's change, right? With x-axis symmetry, the y's change, and with origin symmetry, you always have points that are equidistant and symmetric around the origin. Whenever with origin symmetry, they both change, right? So now let's see how to do a test for symmetry with our example. So we want to know what type of symmetry does this have, okay? So I'm going to get a copy of this, and I'm going to apply those concepts that we just introduced to this question. Okay, let's paste. Let me check the time. Cool beans. So my headphone is about to die. Let me go ahead and switch this one out so I don't lose. I'm gonna let you keep playing though. I like the vibe you were setting. Okay. Oh, let me check one other thing because I know what my devices like to do. They definitely like to, let's go like this. Ooh. Okay, I can hear that. I didn't mean to do all that, but that's okay. My inputs, that still looks good. Let me check this. That looks good. Let's hop back to the tablet. Okay, cool beans. Okay, so we want to test for symmetry here. Let's start off with, what color was the Y? Y was green. So let's do a test. We want to see, does it have Y-axis symmetry? I'm going to put question mark, right? So the test for Y-axis symmetry, we change, let me see, what colors? I didn't use purple. Okay. So the test for Y-axis symmetry, we change, sorry, we did, yeah, okay. We change x to negative x, and then we simplify, all right? So let's do that. So we have y equals, we're going to augment the x, plus 10. We change x to negative x, all right? So negative x squared, as number times itself, double negative becomes positive, right? So then that's going to become y equals x squared plus 10. And then we ask ourselves, is this the original? Yes, it is the original. So we would say yes to y-axis symmetry. Okay, we would say yes there. Let's do a test for x-axis symmetry. I think the x-axis, we did that one in blue. So let's see x-axis symmetry. Okay, question mark. So again, what we want to do here, we want to change y to negative y and then simplify. Okay, so if we're changing the y, I'm going to do a blank set of parentheses for my y. We got x squared plus 10. Change y to negative y. Okay, so notice, no matter what manipulation we do, even if we multiply both sides by negative, we can't get back to the original. You know, if we try to divide or add and subtract, we can't really get back to the original. So since we cannot get back to the original, let me see. Yeah, this is not equal. So x-axis symmetry, this will be no. Right, that would be a no there. And let me do a quick test for origin symmetry. So for origin symmetry, we change both. So change both x to negative x and y to negative y, and then we simplify, right? So we change both of them. So if we're going to change both, we got a blank set of parentheses for our y equals parentheses for the x, right? So then y became negative y, x became negative x, and then when we simplify, we'll get down to negative y equals x squared plus 10. And again, we still cannot get back to the original. So it's the same kind of argument for the x-axis symmetry. So this one will be a no as well. Okay? So the only symmetry that we got a positive test for was y-axis symmetry. Okay, so there's that. And then, you know, we still had the other items as well. But anyway, I'm not going to focus on those right now. Okay, so the only one that was a yes was x-axis. Okay, so let's hop back over here to Pearson. Let's check our work. So we said what? Y-axis. Okay, we're going to click clear and enter. Okay, let me check the chat to see if there are any questions there. Looks good, and I think you can still unmute yourself as needed. So okay. All right. Test the equation for, okay, so now we had the backstory or back discussion on how to test for symmetry. Now we're just going to just do the test. There are faster ways to do everything. I'm just introducing ideas and notions and leaving something for you to discover, because when you discover it, that's when it really takes effect, right? So this is going to be question number 13, because if I just tell you, it don't really sink in. But when you discover it, that's when you get it. Like, I can only kind of point you in a certain direction and kind of nudge you along. But you have to, like, if I'm giving you the answer but you're not looking for it, then you won't see it. You only see it when you're really looking for it, if that makes any sense. I'm going to put we want to do a test for symmetry. I'm just taking some notes. And we have this y equals negative 6x to the 6 plus 5x to the 4. Okay, let's hop over to the tablet so that everybody can see. Okay, let's see the time. All right, so I don't want to keep you for more. We'll go for another 10 minutes. I don't want to keep it for anywhere from 10 to 15 minutes. Definitely not more than 15 minutes. Okay. So symmetry. Let's start off with y-axis symmetry. What color was the y? Y was, I know, blue. Orange was last. I think it was green. So let's do a test for y-axis symmetry. Okay. If we're going to test for y-axis symmetry, we change x to negative x. Okay. So then we get y equals, we got this negative 6x squared, not squared, to the 6 plus 5x to the 4, right? We changed x to negative x, right? So if we have a negative raised to an even power, is that going to be positive or negative? If we have an even number of negatives, would that thing itself be positive or negative, right? It should be positive. So then y is going to be equal to a positive, so it's going to be negative 6x to the 6, because the positive times the negative is negative, right? Hopefully that's not too much going on. Then the next one becomes 5x to the 4, right? Is this the original? This indeed is the original. So we would say yes, right, to y-axis symmetry. Okay, let's do a test for x-axis. I think x I did blue. Let me just check one more time. Yeah. Just trying to be a little bit consistent. Let me give myself a little bit of space. I'm going to shrink this stuff down a little bit, just to make space for me to do some more writing. Okay. So let's do a test for x-axis symmetry. I can't write today. Symmetry, there we go. Okay. So the test for x-axis symmetry, we change y to negative y. I like this feel a lot better, because I feel like just going through the lecture is droning. I know it's still kind of droning anyway, but at least with this technique, it's a little bit more live for me. And I know if it's live for me, it makes it that much more live for you, versus if I'm not really like thinking, you know, because like what I'm really doing is like just kind of bringing you guys into my mind and sharing my thought process and encouraging you to find your own. Because I don't expect you to think the way that I'm doing. I just showing you that it's possible and just offering some direction. But everybody kind of has to find their own way. Okay, so change y to negative y, right? So we got negative y here. Then everything else stays the same. I don't know why I'm so intent on writing squared there. 6 plus 5x to the 4. And I think that even if we factor out a negative or try to multiply, we can't get back to the original. So I'm going to say no here. So there's no x-axis symmetry. And let's do a quick test for origin symmetry. Okay. So let me mention this. This keeps popping in my mind. So there's a theorem with this pertaining to these three types of symmetry. The theorem says that if you have any two of these three symmetries, you're guaranteed the third one, right? So if any two of these are true, then you're guaranteed to have the third one, right? So there's no way, like with that theorem, there's no way that this third one could be true, because you can't have two trues and one false. It's either one is true or all of them are true. Those are your options. You don't have the option of two being true and one being false, right? So, you know, we're anticipating this to be a no, but let's do it anyway. So we want to change both, right? To test for origin symmetry, we change both x to negative x and y to negative y, okay? So let's do that. We get negative y, negative 6. Let me fix my colors. I'll fix it in a moment. Negative x to the 6 plus 5 times negative x to the 4, right? And we changed this guy, that one, and this one. Okay. So now, it's a similar discussion, right? On the left, I think the negative y persist. On the right, those x's essentially go back to where they were. So we get this. which notice this is not the original. So this one would also be a no. Oh, and then another option, we could have no symmetry at all, right? We could have no symmetry. We can have symmetry with respect to one of these notions, or we could have all three be true. Okay. So the only symmetry we got here was our y-axis. Let me see the time. No more than 10 minutes. Okay. Let me hop back to Pearson. Is it symmetric with respect to the x-axis? I think with the x-axis, we got no. So I'm going to hit no. Y-axis, we got yes. And origin, we got no. Okay. Boom. Let me check the chat really quick, see if there are any questions. Looks good. On to the next one. Okay. I want to stop between 620 and 625. Let me see. Okay, let's do another test for symmetry. This is totally okay because this also leaves us with something to work on tomorrow. Okay. So this is question number 14. Let me kind of blow this up. This is question number 14. This comes from section 1147. I'm just going to put symmetry, question mark. And then we have this y equals negative 5x cubed plus 4x to the 7. Okay. Let's hop over here, just like that. Okay. These are the notes that we took. So we want to test for the three types of symmetry. I'm just going to start off with y. Let me see. I know that was last. That was second. This was first. Okay. So for y-axis symmetry, why can't I type today? Y-axis symmetry. Again, we change x to negative x, right? So then we're going to get y equals negative 5x cubed. Notice I'm using my blank parentheses to do my substitution to keep track of my negatives. Without the blank parentheses, it's very easy to lose track of the negatives and make a mistake, right? But when you actually plug your number into a blank set of parentheses, it helps us to keep track of the negative, right? So if we have an odd number of negatives, that negative x cubed is going to come out as negative x cubed. Then what we're going to have a negative x cubed times a negative 5 double negative. That ultimately becomes positive. So that's going to be a 5x to the 4. Again, here we have an odd number of negatives, so that term is going to ultimately be negative. So we're going to say minus 4x to the 7. Okay. Notice this is not the original. If we factor out a negative, we don't get the original back. So is there y-axis symmetry? This would be a no. Okay. Let me shrink this down and let's do a test for x-axis symmetry. And I am watching the clock. I see we're approaching that time. Okay. I'll probably just go ahead and make this the last one. Next was blue. We want to do a test for x-axis symmetry. Question mark. And so to test for this, we change y to negative y. Okay. And simplify. So in this case, we're going to have negative y on the left. We're going to get, let me check something. I mean, I don't think that's the case. Shouldn't be. Users, I think we're good. Yeah, I ain't gonna worry about that. Okay. Everything else stays the same. Negative 5x cubed plus 4x to the 7. Okay. Let's see. If we multiply both sides by a negative, right, we'll get the following. We're going to get y equals 5x cubed minus 4x to the 7. Is this the original? This is still not the original. So I am going to say no to x-axis symmetry. All right, let's do one more test. We got one more. Let's do a test for origin symmetry. Okay, and the test for this, we change change both x to negative x and y to negative y, okay? So let's account for those changes. We're going to have negative y equals negative 5x cubed plus 4x to the 7, and x needs to be negative x, okay? All right. So now, let me see. On the left, we still have our negative y. That first term, we have a total of 4 negatives, so that's going to become positive 5x to the 3. We have a total of 7 negatives on the right hand, on that second term, so that's going to be a negative 4x to the 7. And then to get rid of that negative in front of the y, I'm going to multiply both sides by negative 1. And on the right-hand side, I'm going to distribute that negative 1 to this term and that term, right? So after we account for those changes, on the left, here, let me move this over here so you know that it's there, okay? On the left, we get a positive y. On the right, we get negative 5x cubed plus 4x to the 7. Is this the original? You see it at the top of the screen now. Is this the original? We would say yes. All right, so that means we have origin symmetry. So the only one that we got a positive test for was origin. No y-axis symmetry, no x-axis symmetry, but we did get origin symmetry. Okay. All right. So let's hop back to Pearson. We're going to check our work. Go paper, because I know this is going to be the last one I'm going to do. I need to load these notes for you guys and make them available. Let's hop back here. Okay. Was there x-axis symmetry? I think we got a no there. Y-axis, we got a no. And origin, we got yes. Okay. All right. So I'm gonna let me check the chat one more time. Let me see the time. Yeah, I'm good with stopping here. So if there aren't any burning questions, if you guys don't have any questions, I will let you go. We're going to end the session here. Let me see if there are any other announcements. So the main thing is, we're going to have exam 1. It's going to happen in week 4. With all of our assignments, we get unlimited attempts. You can submit, all assignments are due on a weekly basis, Sunday night at midnight going into Monday. But you can submit any assignment late for a 10% late penalty. We get unlimited attempts at all assignments. And yeah, we still have class tomorrow. I think we go from 5 to 5:50, okay? If there aren't any burning questions, I'm going to let you beautiful points of light go. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.